Hi guys, so today we'll be solving this problem called count good nodes in binary tree. Let's read it. Given a binary tree root, a node x in the tree is named good if in the path from a root to x there are no nodes with a value greater than x. Return the number of good nodes in the binary tree. So a, a good node is a node which has all the nodes before it till the root. All of them are smaller than that node, smaller than or equal to that node. Okay, so that is a good node. So for example here 3, 1 is smaller than 3, 3 is smaller than or equal to 3, so that is fine. So we consider 3 as a good node here. Now we come to the right. 4 is greater than 3 and 3 is smaller than 4, so that is possible. So 4 is good, 4 is a good node. When we come to 5, then we see 4 is smaller than 5, 3 is also smaller than 5, therefore 5 is a good node. Now we come to 1, 4 is greater than 1, so therefore the distance between the root and that current node, if there is any node greater than the current node, then it is not a root node, a good node. So therefore this is not a good node. Similarly in here we can see 2 is not a good node because 3 is greater than 2, so therefore it would not be a good node. So before solving this problem we can see that we need to traverse the whole tree. So for that we need to use a traversal algorithm. So here we can follow pre-order traversal. Why pre-order traversal? Because we need to first identify the roots value, and if there is any value before that greater than the root value, then we need to just uh, make that node as a bad node. Or if there is any value or the current value is greater than the maximum value which is so far in that traversal, then we need to make that as a good node. So that is the intuition behind this problem. So let's solve it. So first I will be maintaining good node count as 0. Okay, and then we'll be calling this function pre-order for traversing through the array, to the tree, and we'll also pass int minimum for storing the maximum value so far. Okay, at the root int minimum would be there because no maximum value has been so far. Then we simply return good node here because we assume that good node counts all the good nodes which are there. Now let's write the pre-order function. Pre-order tree node star root and int max value so far. So this will store the max value so far. Okay, now let's write the base conditions of every traversal algorithm, which is if the root is a null pointer, then we return, otherwise we check. This is a pre-order traversal. So pre-order traversal is middle node, then it is left node, and then it is right node. So that is a traversal. So we traverse the middle node first, and then the left node, and then the right node. Okay, so for that we check roots value. uh, if roots value is greater than max value so far, then we know that greater than or equal to max value so far, then we know that it is a good node. So we increase the good nodes count. Otherwise we check in the left part of the subtree first, and also we pass maximum of either the maximum so far would be the root value, that is we are on, which we are on currently, or maybe it might be max value so far. Okay, and similarly that's what we have to do in the right side. Max of root value comma max value so far. Okay, now this would solve the problem. Let me go through the algorithm again. So we are calling a pre-order function to traverse through the whole tree. Now we check, we are maintaining a max value so far, which stores the max value which we have encountered till now, from the root till that current node. Okay, Now we check if the root's value is greater than the max value so far, then okay, we know that it is a good node. Otherwise, we do pre-order traversal in the left and pre-order traversal in the right, and then we simply return the good node. Okay, let's run the code to see if everything is working fine. Yes, that is accepted. Okay, so I hope you guys understood the problem. Do solve it, and thank you.